In the realm of manufacturing and production, achieving optimal efficiency and performance is paramount to success. One tool that has gained significant traction in this pursuit is overall equipment effectiveness, OEE. OEE is a comprehensive metric that evaluates the efficiency of equipment and processes, providing insights into opportunities for improvement and enhanced productivity. Let's delve into the essence of OEE, its components, benefits, and how it plays a pivotal role in driving operational excellence. Understanding OEE. At its core, OEE is a key performance indicator that measures the effectiveness of a manufacturing process by assessing three primary factors: availability, performance, and quality. These factors are calculated as percentages and multiplied together to yield the OEE percentage. In essence, OEE answers the question, how effectively is my equipment being utilized to produce high-quality products? The three components of OEE. Availability. This factor gauges the amount of time the equipment is actually running and producing compared to the total available time. It considers downtime due to factors like breakdowns, changeovers, and scheduled maintenance. Performance. Performance measures how efficiently the equipment is operating when it is running. It takes into account factors such as speed losses, stoppages, and minor interruptions that affect the production rate. Quality. Quality evaluates the ratio of good products produced to the total products produced. It accounts for defects, rework, and scrap, which impact the overall quality of the output. The formula for calculating OEE. OEE equals availability times performance times quality. Benefits of OEE. Identifying inefficiencies. OEE provides a clear picture of where losses and inefficiencies occur within a process, helping organizations pinpoint areas for improvement. Fact-based decision-making. Data-driven insights from OEE allow organizations to make informed decisions regarding equipment maintenance, process optimization, and resource allocation. Optimized production. By addressing downtime, speed losses, and quality issues, OEE aids in streamlining production, reducing waste, and maximizing output. Continuous improvement. OEE fosters a culture of continuous improvement, as organizations constantly strive to enhance equipment utilization, minimize losses, and boost overall efficiency. Implementing OEE. Implementing OEE requires a strategic approach. Data collection. Accurate data collection is vital. Real-time monitoring of equipment performance, downtimes, and production output is essential. Analysis. Data is analyzed to calculate the three components of OEE and understand areas that need improvement. Root cause analysis. Identifying the root causes of inefficiencies, breakdowns, and quality issues helps in designing targeted improvement initiatives. Improvement initiatives. Based on analysis, organizations can implement initiatives to enhance availability, performance, and quality. This may involve preventive maintenance, operator training, and process optimization. Continuous monitoring. OEE is not a one-time assessment. It requires continuous monitoring, analysis, and improvement efforts to maintain and enhance efficiency. In conclusion, overall equipment effectiveness, OEE, is a powerful tool that empowers organizations to assess, optimize, and elevate their manufacturing processes. By focusing on availability, performance, and quality, businesses can make informed decisions, reduce inefficiencies, and achieve operational excellence, ultimately leading to increased productivity, high-quality products, and improved customer satisfaction.